We are in Maine, and we are now with
Adam Martin,
Adam,
plant manager.
Plant manager.
Plant manager.
Awesome. Well, thanks for taking the time.
Thank you. Absolutely. Good to have you.
Where do we go?
So, welcome to Helical Solutions, Gorham, Maine. We're a manufacturer of high-performance cutting tools. Everything you'll see here is manufactured right here in Gorham. We start with the raw carbide blank, and we do everything right from the CNC through all the prep work, coating, and final packaging.
So you do coating here too?
We do coating.
Awesome.
Absolutely.
Okay.
So we'll start over in the CNC department.
Okay.
So,
cool.
right on this way. So this is our CNC department. Right now in the facility we have the vast majority of the equipment that you'll see is United Grinding Walters base equipment.
Yeah.
And what you'll see here is we really have three sizes of equipment. We have the Visions, the Minis, and the Powers. Okay. They're the same pieces of equipment, they're scaled up or scaled down, and they're just made to handle different sizes, different diameters and lengths of cut.
Yeah, okay. I wish you two could convey smell. It's just this wonderful. It's actually pretty warm in here, and I got to think part of that's just from you got a lot of machines running.
A lot of equipment.
You guys run 3 shifts?
We do. We run around the clock 24/7.
Yeah, wow.
This is a Walter Vision, twin spindles. Each spindle can have X amount of wheel packs, usually up to 4 wheel packs.
Okay.
Typically what we might have for our process is between 2 and 3 wheel packs.
Okay, so this is so strange. It's sort of like a horizontal. You got an arbor, and on it you're actually mounting the diamond. You have to cut carbide with the diamond, right?
That's correct.
So you're mounting your diamond tooling on those arbors, and the stack is not, or the stack is so it can do offsets and cut with multiple tools in the same, without doing a tool change, right?
That's correct.
You're not actually cutting multiple pieces of carbide at the same time.
That's correct. Right. That's correct. So each wheel pack and each wheel on that wheel pack will grind a specific feature or set of features.
Yeah. Okay.
What we'll see on our other side, on our special pieces of equipment, is instead of having a dual wheel pack, would be a single wheel pack and with a wheel changer. So very similar to what you'd have on a Haas or other pieces of CNC equipment.
Sure.
But in this case, we have twin spindle pieces of equipment, 5 axes.
5 axes.
5 axes.
Sweet.
Yeah.
Simultaneous.
Simultaneous.
Yeah. Okay.
Yep. Probing capabilities. Typically on a new part, we're probing diameter, length, but also in the regrind process that you'll see later, we can probe helix angles, depths, diameters. You name it, we can probe it and manufacture to that. Everything here in our facility can run lights out. We have auto loading capabilities.
Oh wow, look at that.
These are the production loaders.
Sure.
And we can set up a pallet with, depending on the diameter, multiple 100 pieces of substrate.
Yeah, right.
Over on the robot side, you'll see very similar, larger capability for stacking sizes. And
so is this a bolt-on from Walter, or are you doing your own solutions for this stuff?
No, this is a bolt-on.
It is.
Okay. It is. Yeah, absolutely.
Very cool. Wow. And insane. It looks like insane coolant pressures.
Yeah.
Wow.
So during the fluting operation, the fluting and the gashing, that's when most of your material will be removed.
Yep.
We have high-pressure coolant pumps that are flooding that.
So the flutes, I think everyone knows what the flute is. That's what you think of as wrapping around the tool. The Nash is the front face of the tool?
That's correct.
Okay.
Yeah, the gashing in the front face of the tool.
Okay, we got to look at that later, because that's something I don't know much about.
Absolutely. We'll hit our quality department when we go over that.
I like the, look at this, folks. We've got some lean, sort of Kaizen tile foam here. I like it. Dedicated tools, something missing. We'll let that slide.
It's right there.
Yeah, right.
Absolutely. Yeah, as part of our initiatives, as you can see from our facility, it's a very neat, clean facility. And one of the things to help improve upon that was, instead of operators having toolboxes and hunting and looking for tools, was to go to a shadow board design where everybody had the tools readily accessible to them. And it really created less downtime and more operator efficiency and machine efficiency.
It's the same Sam's Club cart we use. Different style cart, but this is a Sam's Club cart. No, it's seriously,
Anyway,
this is how the world works. Actually, the one we have is the one behind it there. It's great.
And we have the big brother over there.
That's awesome.
So,
yeah,
they work great.
Okay, so do you, dumb question, do you dress a diamond tool?
Yes, we do.
Okay.
The wheels, we actually will recondition those on another piece of equipment, and basically what you're doing is you're using a silicon carbide wheel, and you're crushing the structure of that wheel. You're breaking the glass bond, exposing new diamond.
Okay, so it doesn't self-dress at all in the carbide?
Not really, no.
No, okay.
No.
And how often would you have to redress a wheel?
Depending on what we're doing, on average, we're probably looking, maybe 500-600 tools before you have to redress.
Okay.
So it's a long.
Yeah, long
But what
time.
you'll see over on the other side, when we're talking large tools, 1.25 inch and larger,
Yeah.
you're going to dramatically reduce that due to the amount of material being removed, right?
But still, I mean, I think about my limited experience running a surface grinder. You're redressing the wheel frequently, very frequently.
Absolutely.
This is very different then, huh?
It is. And really the guiding thing that is causing us to redress is maintaining that corner edge on that wheel.
Yeah, right.
So, perfect.
And so this has a probing system on it? It's a laser system?
So this does have a probing system on it. It has a rent-a-shop probe, just like you would on a regular machine.
Yeah.
And we'll probe during the start of a part when it loads it. We'll probe for length, and then we'll probe 3 spots on the diameter for run out.
Okay.
If it's acceptable, it'll run, and we can control what that diameter and what that tolerance is. If it's not acceptable, it would put it back and get a new blank and put it in.
Okay, yeah. Awesome. And do you know, I know nothing about these machines. I mean, are they hydro bear? Are they special bearing types? Are they special ways, system?
Yeah, so these 4 pieces of equipment are hydrostatic.
They are, okay, yeah.
Yeah. Versus the others are all linear absolutes.
Okay.
Yeah.
So these are faster, smoother, more accurate?
They are. Yeah, these are also your larger capacity machines.
Okay.
So the Visions will grind anywhere from 1/2 inch and up.
Okay.
Anywhere from inch, 1.25 inch, 1.5, 2 inch diameters.
Okay. What's the largest stock tool?
So the largest tool that we've done as far as one tool would be about a 2.5 by 18.
Oh my God!
Large
Holy
tool.
cow!
And fortunately, we do have some large tools over on the other side. You'll take a look at as well.
That's insane. And so, what are the bearings in the spindle that's actually rotating the carbide? Those are Those are actual.
Yes.
What kind of bearings are they?
So that is a steady rest there.
Yep.
And that is just high-speed steel steady rest that it's sitting on. Yep.
Yeah.
So it is a wear item, and as you continue to grind, the carbide will prematurely wear that, but it provides you that support and steady,
backside support,
just like you would on a a lathe.
Yeah, sure. Yep. But sorry, and what are the bearings in the sort of taper nose of this actual axis of the machine? Is that hydrostatic bearing as well?
Nope, it's just a regular collet system.
It is, okay.
Yep.
Cool.
So the Visions, again, would be for anywhere from a 1/2 inch up.
Yep.
If we take a look at the powers, they would be anywhere from the 1/4 inch to 3/4. And then on the minis, we would be looking at 1/8 inch through 1/4.
Okay, so 2 powers and then the
2 minis. Yeah. Okay, thank you.
They're beautiful. This looks like the tool that we were just
That was the
testing
exact
with. Right. I mean, really, there's a fair amount of carbide being removed.
There is.
Yeah. Does that get recycled?
It does.
Okay.
So what you don't see here behind the scenes, each piece of equipment is plumbed by gravity feed back to a central chiller system.
Oh, really?
That chiller system will both chill the oil and actually filter any of the particulate out.
Got it.
And that particulate we can either recycle in filters or in sludge form.
Yeah. Got it. Interesting. Can you explain what carbide is?
So carbide, tungsten carbide, is a mixture of the actual tungsten and cobalt. And typically for general purpose industry, you'd be looking at a 10% mixture, so it's 10% cobalt, the remainder being the tungsten carbide.
So that's the element. Well, no, but you say tungsten carbide, no, it's just tungsten.
Tungsten, correct.
Okay, right.
Yes.
Because carbide isn't, you can't buy nothing, you don't mine carbide.
That's correct. It'd be the tungsten itself.
Okay, so tungsten is the base alloy.
Correct. Yep.
Okay.
And it's usually that, 90-10 split.
Okay. So when people talk about the micrograin structure, does that have to do with how is it a sintered? Is all carbide sintered?
So it's all sintered. So
Okay.
the carbide itself would be both powders, and it'd be either the tungsten powder and the cobalt powder.
Yeah.
They would be sintered, pressed and sintered to size, and then finished ground.
Before they get to you.
Before they get to us.
Got it.
Yes.
So this was never in bar form in saw cut. It was actually
correct.
It was sintered as this length.
That's correct.
Okay, got it.
The grain size itself would be based on what you want to purchase, based on the application. Micro grain, ultra micro, nano grain.
Okay.
Depending on the application, but micro grain is a standard 10%.
Got it. Because that's something we've started to learn and appreciate is not all carbide
is the same.
It's the same.
That's correct.
Doesn't matter what you do to it downstream if the carbide itself is not the same.
Exactly.
Got it.
Exactly. So what you're seeing here is one gripper will unload the tool, the next gripper will load a new tool. Depending on the length of the cut, you may re-grip and push it back into the collet a little further.
It's inchworming the tool in. And it looked like it was blowing a positive pressure to blow chips out of the the nozzle, the collet there.
Give it time to think. And now what it's going to do is it's going to come down
it's going
and
to do the
probe
probing
for length. And it's going to use the paddle of that Renishaw probe, and now it's going to use the tip of the Renishaw probe in 3 places for concentricity.
Yeah.
And if it's acceptable, it'll start. Now these already have a tip preformed on them, as you can see. And it's going to probe it again.
So regardless of how the tolerance with which it's installed, it just updates the coordinate system based on the probe.
That's correct.
So it's not only a QC process, it's also actual going to work location.
Yeah.
Right.
Now this went through an extra probing cycle because of the part of tool we're doing. If you take a look,
so that wasn't
doing a very fine point engraver.
Yeah. Yep. I think that was actually the style of our first Harvey tool ever.
Oh, was it?
That, yeah.
Yep. Yep.
We used to try to put them in our original machine to do engraving, and you can get them in different flat spot tips.
Absolutely.
And, yeah, that's funny.
Great tool.
Cool.
Perfect. So this is some of the legacy equipment with the production loaders. What we're going to see on the next side is going to be the next generation of equipment, which is the Fanuc Auto robots.
Sweet. Let's go.
So this is the next generation of equipment.
Okay, so still Walther though.
Still Walther.
Okay.
Same piece of equipment, same size, same manufacturing capabilities.
Yeah.
The only difference now is the loader on itself. So instead of the production loader, these are the Fanuc loaders.
Got it.
So
you've got an LR mate, and then you just have the trays.
Absolutely.
Cool.
So what it is, it's one unload tray with multiple load trays.
Yep.
The gripper will come in, pick up a tool, it'll sense that it's there, and it'll wait. Once the part is done, it'll come over, remove the tool, rotate the gripper around, load it, and put it back. It's the same principle, just a different piece of equipment to facilitate that. Sure.
And so when you guys run second and third shift, could you not do that lights out?
Absolutely.
Okay.
Yeah, we can run lights out. Typically during the weekend shifts, there is a period in time where we do run lights out unattended.
Do you leave the lights on?
Save power, right? Yeah. Electricity bill's big enough.
Right. Oh my gosh. I mean, the movements are mesmerizing, but it's also not as exciting as machining because you don't have this noise and this visceral chips flying, you know?
It is. It's a whole different process. You're still creating chips. You know, they're just microchips in the grinding process.
So that's actually really awesome. You talk about that.
So the grinding process, if you were to think of it, even though it's a grinding wheel and it looks like it's a flat, smooth wheel, you actually do have the diamond pieces in there that are creating that small 6-shaped chip in there. It's just that it's such a small scale size that you don't see it like you would on a milling process, right?
But you're not rubbing. It's not that.
It's not rubbing. No.
Yeah, it's actually
the
cutting.
diamond has a fracture plane in it that is doing the actual cutting of the tool itself.
Got it.
Yeah.
So as you wear out a diamond wheel, you would end up just generating massive amounts of heat.
That's correct.
Or you see some wear or pushback of some sort. There's some signs that that's happening.
Absolutely, and it would either be the wheel itself is being distorted in shape or size, or the tool. The tool would be growing in shape or size as you lose some of the characteristics of that wheel.
And so is coolant is doing thermal cooling, or is it flushing the chips out, or what's its role?
It's both.
It is.
Yes. It's maintaining the normal temperature of the grind zone, as well as providing that flush to rid any of the product out.
So you're able to make a complete end mill with sort of two, one cup wheel and then the 2 disc wheel?
Correct.
Okay, cool. And the programming happens at the control, or you guys is there cam for?
So the interesting thing about the cutting tool industry is that the programming can be done in one of two ways. you could program offline like you would with Mastercam software, or you could program on the controller itself. It has the same software. What we do as an organization is the specials would be programmed offline, where everything for the production, the catalog side of the industry, for us would have a master program that we can pull from a database.
Exactly.
So same concept.
So this is a saved file run.
That's correct.
Is there a job sheet that tells the operator what tools to load?
Absolutely. We would have our router with all of the
Okay.
related information, just as well as a standard manufacturing facility.
Got it. So do you have a tool room with diamond wheels in it?
Yes.
Okay. Sorry. This is it's so similar but different. Yeah.
It is. You know, the concepts, the frozen tooling, the process sheets, the master programs.
It's all the
same principles. It's just in a different type of application, right?
Cool.
So this is wrapping the radius right now.
Which means it's
so
almost
if we take a look at it, it's doing the corner clearance, and then it's going to do a sticking, and then it'll be a complete.
Boy, I tell you, I mean, 8 minutes to make an end mill is a long time.
It is.
You can see, it's actually pretty cool. You've got a machine simulation graphic, and you've got the actual operation that's happening, and it looks like we've got not much time left at all. So let's see what happens here. Finished end mill with some oil on it. Oh, look at that. That's cool. Should pick up a new blank now. And it waits.
Pretty cool.
Super cool. Yeah. So, and is this the same tool that you're making there?
Same tool.
Okay, this looks like a lot of tools.
This is. So this would be one of our higher production tools.
Got it.
Our batch sizes on these large tools could be anywhere from 800 to 1,000 pieces.
Wow. Why do some of them have the red tops?
Great question. So in our manufacturing process, to ensure the quality, we would do in-process inspection. So we would do a first piece, last piece. We would also do a 1 in 10. And then when the machine runs an auto loader, we would do a load start and a load finish on the auto loader as those bookends.
So those tie back to an actual QC sheet done.
That's correct.
Got it. Very cool. And we wouldn't know yet whether that tool is going to get coated.
That's correct.
Okay, do you cut a tool differently if it's going to be coated?
No.
Okay.
No. So it's the same tool, and in effect, if we look in the catalog, especially in the aluminum series, we would take a base tool, which would be sold uncoated, and we could essentially take that tool and coat it and sell you the coated product and end result.
But I didn't know, do you try to machine or grind the tool, 50 million smaller?
No.
So that the coating...
No, that's a great question. The coating for us would be about 2 micron thickness.
2 microns?
2 microns.
Okay, yeah, so not much.
No, unless you were talking about a very precision reamer, it wouldn't have any effect on the overall diameter.
Yeah, sure. Awesome.
So perfect. So what we would see in these 2 production lines would be all catalog tooling.
Okay.
What we'll see on the next line would be all of our specials production.
Okay.
Reminisce on some of the older equipment. Just
yeah.
like you would have a Bridgeport. This is some of our older equipment that was utilized, not in the same capacity anymore, but it's still functional on a daily basis.
Okay.
For doing the things like chamfers and cutoffs and anything like that.
Yeah.
But this is where it started.
Cool. Whoa.
So one of the differences with this piece of equipment here, this is a straw zack, so it's a different brand of equipment.
Yeah.
If we were to take a look at the Walters that we see, they had a very large pivoting on the C-axis.
Yeah.
So the way that it would form a large radius or a ball would be different than the way that this would form it. If we take a look at this straw zack, the pivot on the head is a much smaller distance. So if you wanted to wrap a ball or any type form, it's a much smaller pivoting axis.
Sure. This is what happens with 5-axis machines. When you try to do a big move, you have to the machine can't even keep up. So to whip B and C around.
Correct.
Interesting. Huh.
And because of that, it gives us the ability to form the geometry differently than on the other pieces of equipment. We could do the same on both pieces of equipment. However, this gives us a little bit more flexibility for the tight tolerances. Because of that, we can do different shapes and forms. Barrel cutters, key cutters, spline cutters.
So wait, do you guys machine barrel tools?
Yeah. Yep.
Really?
Absolutely.
Okay.
So there's this is what we would consider to be a barrel cutter.
Okay. Yeah, so I'm thinking about barrel tools that I think they have sort of like 3 subtle changes in, they look like they are, well, we'll draw it later.
Okay,
But for 5-axis, reducing your scallop height as you step down a sidewall on a 5-axis machine.
Okay, yeah.
But okay. So wait, are you having to grind all the carbide off behind the flutes there?
No, so that might come in as a preform with the head being a little bit
There
larger.
you go. Is that how you do your undercut lollipops?
Depending on the size of it, we could start off with a solid blank and then put the ball and
Yeah.
relieve the rest.
Yeah, there's a lot of carbide to grind.
Correct. And essentially that would be the same for
Yeah,
a product
look
like
at
a T
that.
cutter, correct? We would
Whoa.
come in, this would be a solid diameter, we would relieve here
Yeah.
and taper back up on the angle.
Wow. Is that a custom tool?
That is.
Okay.
That is.
Oh, and that's interesting. Oh, that's so nice. You've got actual relief in the face.
Absolutely.
That drives me nuts. You generate so much heat with those tools because they end up rubbing on the axial faces.
face.
Oh, okay.
Yeah.
And what is that? That is gnarly.
It is. It's just our customer would refer to that as a paper cutter, but it's going into an application and it's basically a small chip breakers on there.
Sure. Wow. And then, what is it, 7 flutes? 6 flutes.
6 fluid on that one.
6 flutes, yeah. And a crazy low helix.
Right.
Okay, so more, which,
High helix on there.
okay, excuse me, high helix, which is going to create more upward cutting action though.
Shear.
Okay,
Correct.
yeah. So because carbide is sintered, so literally a tool starts out as a powdered blank, just like a aspirin pill, and is pressure and heated together. Is there grain structure and length to carbide? Does carbide have a grain?
There is grain size.
Size, but not
Not
direction.
length. Correct.
Okay, so you don't have to worry about cutting with the grain or against
No.
the grain or anything like that.
Correct.
Okay. Got it.
Perfect.
Cool.
So, piece of specialty equipment. It does have a robot for both the part changer and a wheel changer on this one.
Okay.
So very special shapes, very user-friendly to generate those shapes as well.
Got it.
We come down to...
Small footprint as well.
It is.
It's nice.
Yes, it's not, we wouldn't necessarily consider it a high production piece of equipment,
Yeah.
but based on what it's doing, it's not really intended for that either.
Right.
Then we come down to another vision. The difference with this piece of equipment is it does have a wheel changer on the side. So when we talked
Sweet.
about the others having the twin spindles, this
Right.
does have one spindle.
Oh, so that's an HSK 63 or 40?
63.
It's 63. Okay, cool.
Yeah.
Yeah.
So the benefit with having the wheel changers, instead of having the tool wheel packs, once those are dialed in, your tool will run, let's say, flawlessly.
Right.
But once you take that wheel pack off and you have to dress it or manipulate it in any way, you basically have to dress that and dial it back in on your piece of
Got
equipment. Once your wheels are here and on your equipment, you no longer have that dial on top.
So once it stays on a hub or on an arbor, it's repeatable.
Correct.
Okay.
Yes. So what we do have on the 700L is a regrind, a large diameter ball. It's backed off, and what we're going to do is leave the door open and let it run so you can see the whole axis is manipulated.
So you do regrinds
We do.
for anybody?
For our own brand.
No, but if I'm a helical customer, I can send my helicals into you to have regrind.
Absolutely.
Okay.
Absolutely. Now these are some of our larger tools.
Holy cow! Look at this. Okay, so I mean, when I see a part like this, I think aerospace. I think big parts, material removal.
You're correct.
Okay, yeah.
You're correct.
Beautiful. Holy cow.
Now-
Are these stock item or custom?
These are custom.
Okay.
Now these are also regrinds here. So one of the
Oh.
benefits that we have as an organization is anybody that purchases our tooling can send it back to us,
Okay.
and we can regrind it to factory conditions.
Okay.
So it would have the same factory grinds as it would a new tool. Okay.
How many times can you do that?
Well, that's really dependent on the end user's application and how they care for the tool and what they need ground. We could
Okay.
maintain diameter, we can maintain length, again,
Okay.
depending on the application.
So I don't know. Is that a 30 millimeter tool or something, or inch and a half?
These would be 1.5 inches.
So let's say it's 1.500 when it's new. When it's reground, you're going to lose a couple thousandths of an inch on diameter.
You might lose 10 to 20 thou on the diameter
10 to
per
20 thou.
regrind if,
Okay.
if you're grinding the diameter. In the case of these tools, these are ball nose,
Yeah.
so we're only pushing the end back, so we might be losing
Oh.
50 thou on the end.
On the
Nothing-
length, but that's not so important.
Correct.
Sure.
Nothing on diameter.
Sure. Oh, that's great. Okay.
And
But
then
when you
over-
regrind a tool like this, you're not just regrinding you're not just regrinding the axial face, you're regrinding the flute all the way back as
Correct.
well.
And if you take a look at the difference between these two tools,
yeah.
you can see that this is an end and a diameter versus the used tool.
Got it. Wow. It's a lot of carbide right there.
It is a lot of carbide. Now these are some of our larger tools that we do have in stock. And again, these are customs.
So it's just a 2 flute end though?
It is.
Yeah, just a 2
just
flute
a large
end,
one. A 2-inch 2 flute.
Oh my God. Holy cow. That's insane. I don't understand. What do you hold that in?
That's a great question.
I don't even know. I mean, an HSK, I mean, there's so little
to hold on to.
There, yeah.
And you think of the size of mill that must be going into.
Sure.
Absolutely. To spin that, the horsepower required.
Right.
So.
Oh, it's crazy.
And then we also have one of our longest lengths.
That's awesome. Oh my God.
That's roughly a foot length.
12-inch length, so, and it's an inch tool, inch and a quarter maybe?
Inch and a quarter.
Yeah, so still 10 times diameter.
Beautiful tool.
So, when I see solid carbide that has through spindle coolant holes, does that have to be done during the sintering?
Typically, yes.
Upstream of you.
It is.
So you have to then, in that case, you have to set the tool up, orienting it relative to those holes.
Correct. So in this case, this is a through spindle.
Yeah.
And this is the coolant would enter and exit through both the diameter and the end face.
Awesome.
So what our engineering team would have to do is to, in the solid state, design that so that the exit point of the coolant holes would be coincide with the flute geometry.
Yeah, sure. Subject to some probably reasonable tolerance relative to the rest of what you do.
Exactly.
Yeah, but still, okay, very cool.
Perfect. So what we have here is one of our large 6-flute ball noses, and John is going to start this machine and let it wrap that ball.
And is that tool steel support going to come up and is that out of commission for this job?
That would be out of commission for this job.
Okay. Is this spring pass? Like, has it already been ground?
Probably right. Yeah, I'm already ground. Right. No, do it. Take it through it.
Sweet. Cool.
So because of the layout of this piece of equipment, instead of having the C-axis rotate on the base, this has a rotating C-axis on the spindle, and it has an extended bed. You can see that the axis would rotate, or excuse me.
The Y-axis would travel in.
Correct.
It's just for long tools?
It is. It's for long tools. We could essentially do a 24-inch length of cut in one chuck it.
Wow, that's crazy. Sure.
The capabilities.
Traveling along it. Right,
Absolutely.
right. And even on and if it were a corner rat or balling mill, you could even have the tool then swing and finish that in one stroke.
That's correct.
Right.
Versus on the other pieces of equipment with the rotating C on the base, you're limited to that pivot length.
That's cool.
Perfect.
Cool.
We'll head into our inspection department.
Awesome.
Okay.
I'm going to be heading out, but John, it was
Dude,
nice
good to meet you, man. Thank you very much.
Yes, sir. Take care.
More large tools, start and finish.
Yeah. Wow. Cool.
So here's our inspection department.
Okay.
One of the pieces of equipment that we utilize that's unique to the industry is a Helicheck. And what the Helicheck is it uses a series of lights and cameras to visually inspect the tool.
Okay.
And you can see right now it's touching off on an OD.
So this looks to me like what I would see as in a high-end tool pre-center, but I'm guessing this is even more accurate.
Correct.
That's awesome. So it's a black and white image, but it's just pushing a light projection of that tool.
Correct.
That's cool. And then
this
it's auto
picture,
picking
this
out.
would be a shadow.
Right.
If we take a look at the inside,
Right.
we can
Oh my
see it's
gosh.
a series of lights and cameras.
That's really cool. Oh, look at it draw that line. So what is that? I wonder what it was just doing. That's the intersection of two separate flutes there, right?
Correct.
Okay. Almost looks like a compression cutter with that profile, but that's just a coincidence.
Now it's going to switch over to the camera.
Wow. It's actually pretty fast. Look at that. Oh, wow.
And just like a CMM, we would utilize this for a first piece where it could be 100% of the features, and then an in-process where it's only the required features.
Wow. That's really impressive. The whatever the microscope is on that zoom level is insane. What's it doing now?
Focusing.
Oh.
Sometimes it doesn't help with the door open.
Yeah, right. Probably doesn't like.
Yeah.
Doing that.
Uses depth of field.
Yeah.
It just goes back and forth. And it goes out of focus. It should go out of focus and come back in focus. It's using depth of field to.
Got it.
You can find the bottom of that flute valley by checking.
Through focus.
Right.
That's awesome. Yeah, so it's, I don't know if that got picked up on mic, but it's able to actually find the depths of the tool by looking at the focus depth of the tool. Cool.
And then report on findings.
Got it.
Otherwise, a series of cameras, microscopes, run-out gauges.
Yep.
An example of a large special.
Whoa! Holy cow! Just a form tool? I mean,
Just a form tool.
Yeah. Oh my gosh. Wow.
So just as a milling company would have frozen tooling, we have frozen wheel packs. And if we come on in,
What do you said? Frozen?
frozen wheel packs.
Never
So
heard that.
Everything is ground and measured, and each wheel pack would have its related wheel
Okay.
inspection sheet. We number our wheel packs
Okay.
based on our program,
Yeah.
and with all of the associated geometry and measurement in.
Okay.
So that our operators can take these wheel cards and load all that information
Punch 'em
into.
in.
Yeah.
Yeah.
Well, those are all dressed and ready to go. In this case, we do have a plated form wheel for a chip breaker.
Oh, cool. So that little, it is the chip breaker right there.
That's correct.
Very cool.
Yep. But to dress the wheels, we have a piece of rush equipment. It's not up and running right now, but we would load our wheel pack, and it has your silicon carbide wheel
Okay.
that would reciprocate back and forth and basically crush the bond between that wheel and your diamond wheel.
Interesting.
Essentially producing new exposed diamond.
Closing the page. Got it.
Yeah.
But I assume that you can only dress a diamond tool relative few times compared to a traditional aluminum oxide or silicon.
Oh no.
Serious?
Oh yeah. Some of these wheels we probably have a year's worth of life on them.
Whoa.
And we would continue to remanufacture, redress that wheel.
Oh, who knew? Okay. Not what I expected at
And
all.
just like the Heli check that we use for inspection of the tools themselves, we have, this is an older generation, a tool check where we would load the wheel pack in the same series. The lights and camera would measure that
Yeah.
wheel, diameters, angles, distances, and all that information is put on the card and ultimately goes out with the job.
I just don't understand how a diamond wheel that appears to be such a high horse, or how it doesn't load up.
How does it load up?
How it doesn't load up?
How it
You would
doesn't
think
load
it'd load up.
Well, it does load up, and you would have the glazing. You would have the same effect that you would have on a traditional wheel, just on that it'd be impregnated with the carbide.
Right.
Correct.
And so that's when you come back to this guy
Yes.
and redress it.
Redress it, put your form back on, your shape. And
But you're saying it has the potential to run hundreds of tools
That's
before
correct.
that. Yeah, it's
Yes.
crazy.
And that's all due to the flushing, the high pressure
Yeah,
pumps,
got
and we
it.
do have a wheel sticking device that does clean out the wheels in cycle.
Got it. Cool.
So the next department we'll go to is over to our coating. We are under construction. We are adding another coating vessel, so
Sweet.
things are out of order in here a
Yeah.
little bit. So the only thing that I do ask is it could be hot, and we don't touch the tools with our bare hands because the oils in your skin can
Sure.
contact and corrupt that.
You coat the fingerprint onto the tool then.
Correct. So we do have two Platique coating vessels, a Pi 311 and a Pi 411.
Okay.
They do have the same capacity, however the 411 is a newer generation
Okay.
coating vessel. And essentially what we have is a number of cathodes, solid state targets that are in the machine.
Okay.
And what we see here is there's 3 on a door and 1 in the center. And
So-
these are PVD coating vessels.
Okay, so physical vapor deposition.
That's correct.
Okay.
So essentially what's going to happen is during the coating process, there would be a vacuum draw out of there to
Okay.
clear the chamber. The solid carbide, or excuse me, the solid targets are eroded and redeposited electrically back onto the tools. And if we
Okay.
see that, this is what we would end up with.
So you're just putting a sheath over the section you don't want coated,
That's correct. So
and the
basically,
tool becomes the cathode,
the tool becomes
the anode.
no, the tool would be electronically charged.
Ye-
There's magnetides.
Yep.
And there'd be a positive and negative, one coming off the cathode itself that's being eroded and redeposited back onto the tool.
Okay, got
Yes.
it. Yeah.
And in this case, you're exactly right. We put these into holders, and the holder is basically masking the shank of the tool, and whatever is exposed out of the holder would be coated.
But you can cram these things full, right? Because of the nature of it's not like a powder coat where you've got to have line of sight or hope that it gets there.
Correct.
These are suspended in the
Correct.
vacuum, and then
You still need line of sight on these, but these
Oh,
are
you do? Okay.
You do, absolutely.
Okay.
But these are triple action, meaning that the tool would rotate, the whole gearbox
Oh.
would rotate, and the whole carousel would rotate.
Oh, very
So essentially,
cool.
if you did have any line of sight issues, somewhere in that rotation, you would have
okay,
clear visibility to it.
interesting. That's a really cool mechanism. Then that's all geared together.
Correct, planetary drives.
Right. And so how long would a PVD batch take?
Trade secret on that.
Okay.
Yeah.
But I mean, days, hours?
Hours.
Okay, hours. Yeah, sure. But you can fit a lot in there. But right.
Correct. You're probably putting hundreds of tools
Yeah.
in a batch at a time.
And so these are what I would think of as kind of a layman, a sort of a ferrous or steel type coating. This is your
This would be our A+ coating.
okay.
Correct. That would be for your steel applications
Yep.
versus your Z+ coating, which would be for your aluminum.
Yep. What comes into this building that is the coating?
This is your coating.
Okay.
So
Perfect.
those are your solid metal targets. In this case, it's an aluminum or a titanium
Okay.
targets. During the coating process, these would have a electronic charge that goes through them.
Yeah.
And basically would erode this section off of the cathode while it redeposits onto the coating.
Okay. So
Okay.
that's not a filter bag. That's actually the thing.
That is the
That
cathode.
is something solid.
Yeah.
Okay. So that is the sacrificial item. That gets parts of that gets transferred onto the tool.
That's correct.
Okay.
That's correct.
Very cool.
And then depending on the coating, you could also insert gases into the coating.
Okay.
And that's where you would have like your DLC, your diamond-like coatings.
Okay.
Basically, your gas could be inserted, burnt off, creating that carbon exoskeleton.
It's quiet, relatively unexciting, boring.
It is. It's unfortunately, everybody likes to come in and see the coating process, and there's really not much
Much
to see on it.
right.
A lot of it's all happens in the back of the coating vessels inside
Right.
the chamber. They are impressive pieces of equipment, though.
Yeah, it's really cool.
It is. So we're in the process right now of renovating our room so we can add a third piece of equipment.
Oh,
in
wow.
here. Yeah.
Wow.
So that's why we have the work being done here so we can put another piece of equipment
Cool.
in.
But basically, when it was between cycles, you'd open a door, you'd have access to the rack and the carousel, and
You would.
To dry.
Your part-to-part time is very low. An operator would have another rack all staged, ready to go, and he would unload one, load another one.
boom, go. That's cool.
So essentially, if we were to think of these, each coating vessel has a capability of doing about 20 plus coatings. As an organization, we have our A+, our Z+, our T+, and those are our common coatings that we do. We can do other coatings, however, those are more on the special side of the
Right.
application and would be quoted through the quoting and engineering team
Right.
based on application.
Yeah. Does it make sense to leave one machine set up for a particular coating?
Typically, that's what we do.
Right.
Yeah, absolutely.
It makes it a lot easier.
Yeah. Yeah, the changeovers can be extensive in the course of about an hour. You can do a changeover, so we'll try to keep one machine on A+, one machine on Z+ for as much capacity as we have before switching back over.
Yeah. Cool.
Some of our smaller departments, but we do have a cylindrical department. Essentially the same thing as a lathe. However, they are cylindrical grinders that use a large grinding wheel to produce the work. Go ahead, Steve. So we would take one of our standard catalog items that's unnecked, a blank, and we would then turn that into a necked variant.
Okay. Yep, necking the tools down. So it's interesting, it's necked after it's been coated and...
Correct.
Seems odd.
Yep.
Wouldn't you would lose the coat? What am I missing here?
So what we're doing is relieving the diameter, and we are taking this transition off.
Okay, so it goes back. So sorry, this diameter and the end diameter are the same.
That's correct.
Okay, got it.
That's correct.
I see, right there. Got it. So you're really just taking out a center section.
That's correct.
Very cool.
That way somebody doesn't rub on a long length of cut.
Sure.
Typical surface grinder.
Yeah.
Used for weldings. Everybody has one. And we do have a TrueTech. Now these pieces of equipment are conversationally programmed. They use just icons to program, and you would simply select a down motion and give it a velocity and a distance. And what we're doing on this here is we're taking a regular blank and we're prepping it to be a T-cutter.
Oh, very cool.
So we are taking all that extra material out, so when it goes over to the CNCs, they don't have to use their good production wheels to remove that.
That's cool.
Correct.
Okay.
A very easy piece of equipment to operate.
Yeah.
And you can see by the controller, it's all conversational.
Yeah. Cool.
And finally, we end up in our tube and label lasering department. This is where we will laser etch all of our information, our logo, phone number, lot number. Our lot number provides full traceability, so if anybody has any questions on their tool, we can give you all the way back to the material, who ran it on what piece of equipment, all the operational.
So the laser, fiber laser will etch the carbide just fine?
Absolutely.
It looks great, yeah.
And what we have is a small laser for doing the specials, basically 6 pieces at a time, versus a new production laser.
Oh wow, yeah, sure.
Which can
That's awesome.
do 100+ pieces at a time.
How many?
100+.
Yeah.
Depending on the length, we can put a backstop in the middle, and you can put a part on either side.
Cool.
Runs very simple. You just simply scan into your router. We have barcodes for what the part is.
Oh wow.
And then you just scan all that in. It loads it all automatically.
Pulls up all that.
Parts.
Got it.
It's like a start.
So we are with
Harrison Sheldon.
And you are?
I am a manufacturing engineer here at Helical Solutions.
Awesome. Cool.
And we have a Haas VF2SS that I'm going to do a little milling demonstration.
Okay.
Nothing crazy, nothing to blow your pants off design-wise, but we're hoping to make some chips and make some noise.
So that's an uncoated helical?
Correct. That would be our 3-flute chip breaker for roughing purposes in non-ferrous materials.
Yep.
So today we got some 6061 T6.
Yep.
And we're going to slice through it at 10,000 RPMs, 350 inches a minute.
Okay.
With a 150 thou radial and an 875 axial, which gives us about 46 cubes.
Wow, 46 cubic inches a minute.
Yep.
That's cooking.
And
that's got to
for this little guy, that's going to put us at like 80%.
Right.
Which is why I didn't go too much further than that, because the tool itself is capable of a lot more than that. But this machine is going to tap out, so I wanted to keep it reasonable.
Do you know what the chip load per tooth is at that?
Yes, it's 11 thou 7/10 without the chip thinning. So with chip thinning, it's 9 thou 3/10.
And so you're saying it's 150, so it's a 20% step over?
Yep.
Yeah.
20% step over.
Sweet.
And almost a full axial engagement.
What's the holder? Is it hydraulic?
Yeah, that's a hydraulic shunk.
Shunk, nice. Very
Cat
good
40.
Stuff. Yep. So this has got the flutes or the chip breaking action ground into it. So talk to me about what the chip breaking actually is going to do on what clearly here is going to be a relatively open cut, right?
Yeah.
So I don't need to, it's not like I'm slotting where I want to get the chip out from a tougher ID area.
Correct.
Right?
So with peripheral cutting like this, the chips typically will fall away from the cut, so it's usually not that big of a deal. But if you're going to incorporate some pocketing routines or anything like that where chip compaction might become an issue, that's where it's really going to benefit you to make those chips smaller and get them out in time.
Okay.
In this case, it'll help a little bit reduce the heat, a little bit just flush them the chips out of there.
Right.
But yeah, in the periphery cut, it's not as important.
Not as important. Got it. Okay.
All right. Ready to make some chips?
Let's do it.
All right.
Awesome. I've never used the cube before.
Oh, no?
We'll see how it goes.
Sure. Just skimming from the previous pass.
What coolant?
It's a water soluble, running about 8%.
And do you find, the bricks level will actually correlate to tool performance?
What is that again?
The concentration level, the bricks level, the coolant.
Oh, you know what? To be honest, I haven't done much testing with that, but I do find in the 5 to 10% range. I haven't encountered any issues with that, and that's what was recommended to me by the supplier. So
looks good.
Yeah, I mean for a heavy rough and cut, it's not too bad.
Right.
I mean these chip breaker tools, you can get them to provide a decent wall finish, but then again, they're a rough and cutter, so you come in with a higher helix. Well, these are a 45, but you come in without the chip breaker, and and you take a lighter cut, obviously, but not too light. You know that. All right, so you want to check that out, or how are we going to do?
Yeah, 46 cubic, that's what surprised me was at that material removal rate. I mean, we had this exact machine. It was actually really quiet. It wasn't bad
I've made a lot more noise with less. Yeah. All right, so let's get at it.
Are you able to hold the tool with less stick out in that hydraulic?
That one is pretty much bottomed out.
Oh, okay.
So what I did was I took this off the production line over there, and you'll get a tour over there later, but so that's supposed to be an RN tool, a neck tool. So it's on a 4-inch overall rather than a 3-inch overall.
Okay.
But it was prior to the necking operation, so I treated it as if it was a like a stub of that series.
Yeah, right, okay.
Yeah. So unfortunately I'm bottomed out there. But playing around with my numbers, as far as the tool is concerned, there'll be no issue if I stuck that out on a 1/2 inch or
Serious?
so. Yeah, there wouldn't be
more stick out, really?
There wouldn't be any problem. I could stick it out another 1/2 inch and it wouldn't affect it.
Okay.
Beyond that, it would start to extrapolate an issue, but here we go. All right, so this will be 3 laps there.
Spring pass.
Yep. All right, we got 1 lap left.
Really does sound great for that removal rate.
You can smell the coolant now. Got a little warm.
Got warmed up?
Yeah.
Yeah.
And we left a little wall. Perfect.
And the GoPro light's still blinking, which means it is waterproof. I wasn't sure. I've never used it before. Yeah. Okay, so now did you stop? I've heard that you can actually damage tooling when you go to machine that last little strip off.
Absolutely.
Okay, so talk to me about that.
So in that scenario, rather than continue with my radial depth and increase to the point where it reduces to nothing, that chatter will start to chip the OD of the cutting tool.
Okay.
So what I'll do is I'll leave about my radial depth of what I'm taking. So in this case, 150. I'll step over about half the tool and I'll plunge through the whole thing.
Go straight through it.
Right, to keep that vibration from flapping.
So you're basically cutting on the center line of the tool?
Yeah, essentially.
Okay. So you're going to be doing,
If I was to clean up a thin wall, that is.
Got it. Okay. Awesome. Can we blow off a little bit of the floor? It's interesting. I don't know if there's an element of the cutting tool that helps, but we've often found that roughing tools give phenomenal floor finishes. This is going too fast for that, but sometimes going at the same feed rate with a roughing tool for our corn cob style tool actually gives a really good floor finish.
Yep.
I don't know why.
In this case, for our geometry anyway, the end geometry on this tool is pretty much identical to the end geometry on the finishing tool itself. So therefore, our chip breakers are out of the equation at that point.
Right. Okay. Cool. Thank you for the demo.
No problem.
And so this machine is part of the production line, or you guys just use it for testing?
No, this is for R&D purposes, product testing. Yeah, if a customer has something they want to test, we'll do a little sample cut here.
You joke about chip size or care about chip size, but it makes a big deal. And on this machine, it's funny, we didn't realize this until we got our VF2. In fact, they don't even have the conveyor on this machine. But
no, it has a space for an auger.
Yeah, right.
But we didn't get it.
Right. But what we didn't realize on our VF2 compared to our other machine is that the auger doesn't have any moving parts in it. So you have to wait. You can't switch your chip bins out when you switch materials until you flush out all the residual stuff in the auger. And so having consistent chip sizes that drain the coolant actually really does matter.
Oh, very cool.
Anyway, cool.
As a small business owner, what's awesome to me is not just to see how Helical makes their tools and how they run their factory, but also how do you handle not only shipping out the orders, but just stocking your inventory. Let's head back down to Massachusetts at the Harvey headquarters where Helical now does all their order fulfillment.
You can take a look down here, and it's the same setup. Everything's in numerical order, top to bottom, left to right, front to back, but just naturally, Helical Solutions product is so much bigger than Harvey's Micro.
Right, that's awesome. One of the things we really like is that EDP number is great for just simply looking up the tool, but also tying in with the new speeds and feeds calculator that they are calling Machining Advisor Pro. Not Milling Advisor Pro, Machining Advisor Pro.
Yeah,
it's awesome.
We're pretty proud of that. So, as you may know, we
make sure
just
put it back in the right bin.
Absolutely, I wouldn't.
It's much easier to catch that mistake on when you're watching this on the internet than when we're in real time.
One of the things we can show you is we pulled out some tools for the new catalog that just dropped, and we still have some on the Harvey side if you feel so inclined to see.
So Helical get filled on a separate line?
It does, absolutely. So currently Helical runs off of a different ERP system.
Got it.
So the whole actual step-by-step process of order fulfillment is different. So when we set this up, we gave it its own area, its own line system. We didn't want to also run the risk of confusing, you know, two brands, one box. So we keep things very, very separate and organized. Some of the new product we have, if you want to check it out. 3-flute corner radius.
Coolant through.
The coolant through ones I always think are the coolest, just because I can't imagine conceptually how we actually get down in there. And
well, so it's interesting because, and this is outside of my wheelhouse, but my understanding was that a lot of the coolant through stuff was sintered, which is where they take a powder and press it together around a mandrel. But I don't know that that can be done with this as solid carbide. We'll have to talk to the guys up in Maine.
Absolutely, yeah. You're going to be talking to Brian and Adam, and they are far more knowledgeable than me. I just pick stuff up and say, that looks really awesome.
That's beautiful. 3-flute corner rad, coolant through, high balance, reduced neck, which, 33,000 RPMs. It's awesome. Cool. What else we got? Okay,
Yeah,
7-fluter. Okay.
Yeah. This one's just, I think this one's just beautiful.
Yeah, these are beautiful. This is awesome. So we were just talking with actually Tyson Lamb, who's running in an Uber truck, and he keeps adding flute count, reducing radial engagement, and increasing the feed rate to get higher material removal rates, longer tool life. Pretty cool. It's so strange to think that taking, you know, a 50 thou width of cut with a tool like this is actually the recipe, but very cool. Yeah, there you go. High temp steels, alloys, titanium. Cool. Is there a rhyme or reason behind the green?
Possibly. I think it was so bright, it's eye-catching. It's
It
definitely
is.
noticeable.
Right.
It's not, I don't believe it's a standard stock color from the manufacturer. I could be incorrect.
Sure.
But I think they wanted to really stand out.
Like I always see it. When somebody opens a drawer at a shop and I see that, it just has like the color that just pops.
Yeah, absolutely.
Okay, so 5-flute, corner rad, chip breaker, variable pitch, same sort of, you know, steel, alloy, titanium. Oh, look at that stubby guy. Okay. So variable pitch, I'll have to ask the guys up in Maine if it's also a variable helix. A lot of times that's what we'll see. So 5 flutes,
meaning they aren't actually evenly offset from each other. But here it may just be the variable pitch, which is going to change your engagement as that tool rotates through the part and can help with harmonics. Heck of an edge breaker, actually, more than I'm used to seeing in that guy. Awesome. For the folks that follow the Business of Machining podcast, you'll get a kick out of this. So we have the $330 version. This is the approximately $1,000 version. This is electronic. So when you hit the number, it'll dispense that number of inches of tape, but it also heats it, which is really nice because it actually cures on the box quicker, which speeds things up. But when I first bought mine, that was $300 was expensive enough. $1,000 was hard to digest. I do get this though.
We love this thing.
Yeah, isn't it funny?
It's really fun.
Yeah. So you guys use the gummy tape? Can we push? Can we stick some out?
Absolutely. So we have right now it's just the paper dry tape.
Yeah. Oh, that's fast, and that's already wet. Oh, that's nice. That's really fast.
Yep.
Holy cow.
Yeah. When we
can we do that again?
Absolutely. When I went up to Gorham and I was working up there with the guys, they put me at the station.
That's so fast. That's
and
awesome.
I thought this was the best thing ever.
Yeah, it's amazing.
It was so fun.
Amazing.
I was like a schoolgirl. I was giggling.
Right. And like we pay probably a little bit of a high price for gummy tape because we don't buy that much, but it's still so cheap, and it gives us custom packaging. It looks great.
Yeah.
That's fun.
Reinforced tape. It's a lot of, Helical tools are bigger. You know,
Yeah,
if they're
right.
going to be bigger, they're going to weigh more. So you want to make sure that, we even switched from standard bubble wrap to dual-sided bubble wrap bags.
Oh, look at that. So you've got preloaded bags kind of.
We do, absolutely. So every night and every morning, the team will pre-make the boxes, pre-make the paper.
Yeah.
And so when you get a product, what you should see inside is a sturdy box with paper in the bottom, a bubble wrap bag.
Oh, with the tool inside that.
The tool inside.
Now, do you face the bubbles in or out?
The bubbles are out.
Okay.
Yeah. And so your tool should be inside that bag, taped up in the box, another layer of paper, the reinforced tape, and then the label over that.
Got it. So, and is it up to the picker to decide the size box?
It is.
Okay.
Yep.
You just have a limited number box.
Yep,
Got it.
absolutely.
Very cool. It's funny, the little things, but
Yeah.
it's awesome. Okay.
Yeah, it's
Look at
it's
all the
pretty
green.
great.
Thank you for showing us around
My
the warehouse.
absolute
It is no
pleasure.
small feat. Like as a small entrepreneur, like the consistency of order fulfillment, and it's easy to fulfill orders when they're 3 a day or 10 a day, but when it's 180 a day, or it's incredibly difficult to do well.
Well, I have a great team, so it's not me, it's them. But it's been an absolute
Thanks,
pleasure.
Megan.
Thank
Appreciate
you
it.
for your time. Enjoy Gorham.
Thanks again, folks, for watching, and a special thanks to the folks at Harvey and Helical Tool for letting us come tour their facilities in Massachusetts, in Maine, and see how they grind those tools. Take care, folks. See you soon.